Okay. Hi guys. Dun-dun-dun-dun. So let's start with these questions and let's discuss in a while. Dun-dun. Yeah, do these questions and once you're done, raise your hand in Zoom. At 5:15, we're going to start the discussion. Why only 20? People are still joining. Thing is, this week, certain schools they have the exams. So some people they're having exams tomorrow, so they're studying for the tomorrow's exam. You know, that's why the count difference. Once you're done with the question, raise hands, Zuma. Yes, walaikum salam. Hi, hi, hi. Today also at the academy. Actually, just now I came to the academy. Again, the was day works are going on. But before this, I was at somewhere else. Yeah, Fadil. Okay, do this question. Once you're done, raise hands, Zuma. All the questions. Okay, sorry on the gap, guys. I was doing a small skip. Uh, Not exactly Homera, but somewhere, somewhere. Until later. I'll think of a reason until later. Okay, let's start. Those who done with this question, raise their hands up. I can see four people have raised their hands. Others were sleeping all this time. Guys, didn't you all do the question? Only the first few. Nah, whatever I share, screen share kar bokko ma. Lazy fellow. Didn't you know? Hi, hi, hi. Okay, let's start. First question. Which of the following is the hexadecimal equivalent of octal 1156 base 8? 1156 base 8. 1156 base 8. So, I mean, you're doing it very, you're not doing it even I say talking with someone, I guess. Or else you were sleeping all this time. Then what were you doing? Yes, Amara, why is anything special tomorrow? Don't tell lies, Rashida. Okay. So in that question, they ask us to convert from octal to hexa, no? Okay, let's see. Ah, is it? So basically, oh, this is Riafa, sorry. You can rename your name, Riafa. I given the option to rename. So basically, what you called when you're converting numbers from octal to hexadecimal, there is no direct method. So we have two indirect methods. One is you can convert this number to decimal, and the decimal answer you get, you can convert that to hexadecimal. The other option you have is you can convert your answer to binary, and you can convert your binary answer to hexa. Out of the two options, what is the easy option? Perfect. Out of the two options, the easy option is the binary option. Okay. So we are going to convert from binary. Right. Now, when you take hexadecimal number system, octal number system, octal is number where every character is representing 3 bits. So we are supposed to find what are the 3 bits hiding behind number one, what are the 3 bits hiding the second number one, what are the 3 bits hiding behind number five, and what are the 3 bits hiding behind number six. That's our task. Okay. To do that, there's a very short method we have just below every number, write 124, 124, 3 bits, no? So write 124, 124, 124. And then circle the numbers you need to form the respective digit. To form one, need only one. To form one, need only one. To form five, we need four and one. To form six, we need four and two. Okay, so I circle the numbers I need to form the respective digit. Below the numbers I circled, I'm going to write 1. And below the remaining numbers, I write 0. And now, if you join them all together, your final answer is going to be 001, 001. The left side double zero is not needed actually, the first one. Anyways, I'll write everything as it is below. 101, 110. So now I have figured out what are the 3 bits for every digit. 3 bits for every digit. That's done. Now I have done the first step. This first step is done. Second step is to convert the binary answer to hexadecimal. So if you all can remember how hexadecimal is created, I told you hexadecimal was a number system that was made to shorten binary. No. So how we shortened is we grouped how many bits as one digit. Noctal is 3 bits one digit. Hexa is what? Perfect. Hexa is where we group 4 bits as one digit. So if you group 4 bits as one digit, these 4 bits I is going to represent one set. These 4 bits are going to represent another set. And these 4 bits are going to represent one, two, three, four. These 4 bits are going to represent another set. Double 1 0, 1 0 1, 0 0 1, 0 0 1. Okay, so these 4 bits are going to represent another set. So if I 4 bits as so if I segregate them properly, I'll have one set as double one, triple 1 0. I'll have another set as 0 double 1 0. I'll have another set as double 0 double 1, 0 0 1 0. These are the three sets I have. Okay, I've separated them into 4 bits by 4 bits. Now I had to figure out what is that one digit these 4 bits are representing, what is the one digit these 4 bits are representing, what is the one digit these 4 bits are representing. For that, we have a shorter method. Just write 1 2 4 8. Basically, this 1 2 4 and 1 2 4 8. The meaning is the binary place values. The binary place value goes like this: 2 to the power 0, 2 to the power 1, 2 to the power 2. This is how binary place value goes. That's how I get these numbers 1 2 4 8. That's how I get these numbers for information. Anyways, to convert, I'm going to just write 1 2 4 8, 1 2 4 8 below every number. Then, wherever 0 is there, you cut that place value. Wherever 0 is there, you cut the place value. 0 is there, you cut the place value. Okay. And then you have the sum of the remaining. So here the remaining is going to be 8 plus 2 plus 4. That's 10, 14. Here the remaining is basic 4 plus 2, which is 6. Here the remaining is just only 2. Now, when you take this hexadecimal number system, we learn that it is a number system where 4 bits, meaning 500 digits, are representing one. 4 bits are representing one digit. Now, if you look at the second set, the what I call left side corner set and the middle set, these two sets, you can see 4 bits are representing one digit. 4 bits are representing one digit. But if you look at the right side corner set, 4 bits, it's not representing one digit, it's representing two digit. So in hexadecimal, whenever you have a two-digit number, meaning numbers like 10, 11, 12, 13, 14, and 15, in hexadecimal, whenever two-digit numbers are there, without using numbers, what do we use? Exactly. Without using numbers, we use alphabet letters. So that goes as A, B, C, D, E, F. So based on that, tell me, whenever you have a number called 14, how is 14 represented? How much? Perfect. 14 is represented with the letter E. So now again you join them together. Once you join them together, your final answer is basically 26E base 16. Okay. So this is our final answer. So if you double check with the question, you have this answer, first answer. That's the correct answer. You got it correct, then mark it correct. Yeah. If you have any questions, drop in the chat. Sorry. Amara wants to copy the following 4 files with the given file sizes to USB drive. A invitation document of 15 KB. There's no, Mira, I was talking to one of the students here. My wife is, she has gone out. Sad life. Can I get the paper PDF? I'll share it in the group after class, okay? By the way, those who are not there in the paper class groups, there's a separate, like a WhatsApp community for the paper class. The people who are not there in it, I'll share the link. No, by the way, yeah, you're spreading rumors. I'm living a very happy, satisfied life. Will your wife come for the awards day? I don't think she'll be in Sri Lanka that time. Oh, will she be in Sri Lanka? I remember. Okay. So we have 15 KB one file, 26 MB another file, and then 150 MB another file, the concert.mp4. No, Zaki. You're sending her alone. Yeah, Aja. She's a strong woman. What to do? 28 KB one file. You have named your name as Hajan, rename it. What about the kids? The kids are at home having fun. Oh, Fatima. Why is she always out? She's working, Nimi. Shaza. She's a doctor, right? I think these number conversion broke my brain. Sad life. Yeah, fuck. She isn't real. She is real. No, not like that, Fatima. I have shared their names, Amara. You have forgotten. No, if they have woken up, the thing is they are playing. And I'm not at home. I'm at the academy at the moment, so I can't show you. No, no, I have two kids as well, Humaira. Okay. So what do you call from the following four empty? Because they called and told me. From the following four empty USB drives, a given capacity, which is the most economical drive that can be used to store the above files. Ignore the space in the USB drive that is required for file management. Okay, fine. Exactly the answer. Yeah, yeah, Walid. Show us a wedding album. Well, yeah, Hafiz. What to do? Okay, come back to the topic. Focus, all of you. So the question is saying to store all these files, what is the file size of a pen drive they can buy? And it should be economical drive. So what do you mean by economical is that means if you're spending what do you call money to buy a pen drive, you all know when the file size increases, okay, when the file size increases, even the price of the hard disk increases. Okay. So the question they're saying, what is a pen drive we can buy that is economical, meaning we are not spending more than what is required, the cheapest technically. Okay. So let's go through the answers and let's check one by one. The name was Hala and Haya. Was it your kid? Yeah, yeah, yeah. Where was your wedding held? It was held at Burj Khalifa. The funny thing is, I think I once named the cat. Sad life, Zaina. It's the truth, man. It's the truth. You can't believe what can I do. That's why I said certain things might seem impossible, but it's actually possible. Yeah, that's because I'm a trillionaire. We're not a millionaire. Okay, coming back to the context. Focus on the question. Now, when you look at these file sizes here, you can see there are different amounts mentioned here, right? When you're adding values, can we add values that are in different units? Like, can I just blindly add 26 plus 15 plus 150 kilo? While they're in different units, can I blindly add them together? Good job, Moad. That's also true, Alpha. What is Hannah? Let's see, Hannah, Amara. Exactly. You can't add, okay? How do the lie she have, says it, Father? Let's see, Amara. I don't have so much money, Atika, what to do? Okay, come back to the context, okay? So yeah, when they're different units, you can add them together. So in order to add them together, all of them have to be in the same units, okay? All of them in the same unit. So let's add them, we can add them together. But for now, let's add the things that are in the same unit below. So if you add the units that are in the same units, you can see here, in MB, we have a total of 176 MB. What is the total of the KB values given? Yeah, I have Humera, but it's in stocks. It's like in a not in liquid asset. Exactly, no, but Fatima is like, you have to keep a class to talk about your gossips. വേലല്ല. I'm asking you a question. I'm asking you what is the total of the KB here, man? Half of you are not in this world as well. Come to this world. Learn the real different world. The total of the KB. MB is 130. Come on, kila ivarai. Why is it all of the all day? Hmm. Inshallah, Mara. Exactly. Can understand. The KB total is basically 28 plus 15. That's 30 plus 15, 45 minus 2, 38. 28, 30, 45, 45 minus 2, 43. Okay, so that's going to be 43 kb. Okay, so now we have a minimum of 176 MB. We have a minimum of 176 MB. And in kb, we have 43 kb. Now tell me, is 43 kb more than 1 MB or is 43 kb less than 1 MB? Is 43 kb more than 1 MB or is 43 kb less than 1 MB? Exactly, Hannah. Yes, as a focus. Correct. 43 KB is less than 1 MB. So now tell me, I have a file to store now. Okay. So this, let's say this portion is what do you call oh, let's forget about that. Let's say this 43 KB file is there, right? Inside 1 MB space, can I store this 43 KB file? Okay, so Mera. Tell me, in 1 MB space, can I store this 43 KB file? Yes, because 1 MB is equal to 1024 KB. Okay, 1 MB is equal to 1024 KB. So that means if you have 1 MB space, it's more than enough to store this 43 KB file. It's more than enough for 43 KB file you can store. So that means initially we have 176 KB or 176 MB for this file, and this file we need 176 MB. Then if I add these two, it's less than 1 MB now. So based on that, tell me, is 177 MB? If we have a pen drive that can fit 177 MB, is this storage more than enough for us to store all our files? Is 177 MB more than enough for us to store all our files? Those who are saying no, why no? To store these two, I need 176 MB. Okay, to store these two files, I need 176. So my question is, in 177, can I store all the files? Yeah, because the file, because basically, if these two are taking 176, my indirectly what I'm asking is, within the balance 1 MB, can I store these two files? Yes, the balance 1 MB, I can store it. So that means 177 MB is more than enough for me to store all the files. Is that part clear, all of you? First of all, tell me that. I will clear the point, all of you, all that 177 MB is more than enough to store all these files. Shall did you get that part? Fatima, come. Okay. So basically, again, I'll tell you all. In this question, what they're saying is there are four files: invitation document, yesterday.mp3, concert.mp4, tajmahal.jpg. The question is asking, can we store how much of storage we need to store all these four files? Okay, the question is asking how much of storage we need to store all these four files. Okay. So if you take the addition of these four files, adding values, always the units has to be same when you're adding values together. Okay. So if you look at this question, what it is, there are two values that are in the same unit MB and there are two values in the same unit KB. So when I added them together, I had here the values mentioned that the total MB is 176 MB, the total KB is 43 KB. That's a file size of what I have. So I have a total of files that are 176 MB plus 43 KB. Now I want to see how much space pen drive I need to store all these files. So my question that I asked was, I was like, okay, in a 176 MB file, 177 MB pen drive, let's see if I have a pen drive of 177 MB. So my question was, in this pen drive, can I store all of them? So the answer was yes, you can store. Because one, if I out of 177 MB, if I go and store this part, this will take 176 MB. And then the balance 1 MB is that in the balance 1 MB, only a small portion this will take. Because 1 MB is equal to 1024 KB. Is that clear, Fatima? Why did you take 177? That was the smallest number I could take as a whole number. Like 176 is not enough. Because in 176, I can add only the S3.mp3 and concept.mp4. Only these two files I can put inside 176 MB. I said smallest, minimum, minimum, minimum. The smallest whole number. Got it, Fatima? The smallest whole number I'm saying. In terms of MB. 200 is greater than that, no? Okay, perfect. So now, based on that, tell me, can I store all these files? So basically, minimum I need around, if I'm taking as in terms of MB, as a whole number, I need minimum 177 MB. Okay, if I'm going to deal with whole numbers only. So based on that, tell me, all these four files, can I go and store inside this pen drive? If I have a pen drive of 128 MB, in this pen drive, can I store all the four files? No, I can't. In the remaining three pen drives, 1 GB, 2 GB, and 256, in the remaining three pen drives, can I store? Yes, the remaining three also I can store. In the 1 GB pen drive also I can store. 2 GB also I can store. 256 MB also I can store. Because why? I just want 177 MB. I just need 177 MB. Okay, so 256 is greater. 2 GB is also greater. 1 GB is also greater. If you are wondering what is the relationship between GB and MB, 1 GB is equal to 1024 MB. So there also it's more than enough. Okay. Now, I told you a while ago that when the size of the storage space, in terms of size, when I'm referring for the storage space. So when the storage space of the pen drive increases, the price also increases. No? So based on that, tell me, out of option number one, option number two, and option number four, what do you think will be the most expensive pen drive? I'm still confused how you got 107. I'll explain. Give me a moment. Correct. 2 GB is the most expensive. Now we want a cost effective one. So out of option number one, option number two. So one, two, four, all of them can store the data. Out of one to four, what do you think is going to be the cost effective one, meaning the cheapest one? Perfect. It's the option number four. So that's the correct answer. Okay. I'll focus, I'll tell you here. 15 KB and 20 KB. Ala, first of all, tell me, are you clear that in this question there are four files of these different storage values? Is that part of the question clear for you? That there are four files and these are the respective storage space. Perfect. Now, Look at all four values and tell me, are all of them in the same unit? No. So you can see there are two units used. One is KB and one is MB. So look at the MB values and tell me, what is the total of the MB? Hey, I didn't still check, so I'll check. When I check WhatsApp, I'll reply. Perfect, 176. What is the total of the KB? Perfect, 43 KB. So now, if I want to store all these files, can I store all these files inside a pen drive that is 176 MB? No. After 176, what is the next whole number I have? Perfect. 177 MB. So now my question is, okay, in 176 MB, if you can't, in 177 MB can be? Yeah. The reason is because inside 177 MB to the 176 MB file, yes. After we store 176 MB, like these two files, after we store these two files, what is the balance space we will have? In that 177 MB pen drive, let's say, if you store these two files, what is the balance space we'll have? Perfect, 1 MB. So within 1 MB, so 1 MB is equal to 1024 KB. No, 1 MB is equal to 1024 KB. So within the 1 MB balance space, can I store the balance two files? Basically, 1 MB is equal to 1024 KB. So inside 1024 KB, can we store 43 KB? Can we store this here? Yeah. So that means inside 177 MB, we can store all these files. Is that part clear? Inside 177 MB, we can store all these files. So how I got the 177, I was like, that is the minimum number of MB we need. Like if I'm going to deal with whole numbers only, without dealing with decimal numbers, if I'm going to deal with whole numbers only, I need a minimum of 177 MB to store all these files. That is what I said. Correct. Hala? Let's see Surya now. Okay, perfect. We got the remaining answer how I found 256, right, Ala? With that was the cheapest or the remaining. Okay, so basically, are you clear that we can't store that file inside the 128 MB? Yeah, because that's more. Are you clear that in option number one, option number two, option number four, in all three options we can store the file in one, two, four? Perfect. Now, when you take storage devices, when the size of the storage device increases, the price also increases. The size increases, the price also increases. So out of the remaining three sizes, if you take 1 GB, 1 GB is equal to 1024 MB and 2 GB is equal to 2048 MB. These are sizes in MB. So you can see out of the remaining three, 2 GB is the largest number, right? So that means out of the remaining three, these are the most expensive. These are the second most expensive and these are the cheapest. So the question is asking the most economical drive that you can store all the files. So if your purpose is to store all four files only, then the option number four is the most economical option, meaning the cheapest option. Is that clear? Perfect. What if you put the answer as 1 GB? That's wrong. 1 GB and 2 GB are not the economical one. You can store in both of them, but it's expensive. Okay. So if you mention option number four, mark it correct. Put one mark there. I can do this question in few seconds, Humera. To explain only, I'm taking this much time because it's the first time you're getting these kind of questions. It is easy, man. For me to complete these 5 questions, 5 minutes is more than enough. So I gave you 10 minutes. Good, mashallah, good job, Mara. That's why I gave you double of the time. When I said I need 5 minutes, I gave you 10 minutes. Next question. Okay, I'll give you a time to do this remaining paper. Don't worry. Focus, all of you. So the question says, consider the following character slash value mappings for the ASCII table given below. Okay, so in ASCII they are given in ASCII coding system. The letter O is represented by 79, slash is represented by 47, capital L is represented by 76, simple O is represented as 111, and so no, 111, and simple L is represented as 108K. They have mentioned here. So the question is asking, what is the ASCII which of the following will be the ASCII representation for O level in binary? Sad life. First one as in? I didn't get your point, Humaira. You mean the third lesson? Did you create the summary, Humaira? I asked to make a summary. Make that summary. One page summary. You make the one page summary and then get just paste in your wall and keep, and gradually you'll remember it. Okay, focus all of y'all. Now they are asking what is the ASCII code for the word O level? Okay, they're asking what is the ASCII code for the word O level? Now, if you look at the word O level, how many characters you all can see here in total? Perfect. There are three characters. ASCII is a coding system where every character is represented by 7 bits. ASCII is a coding system where every character is represented by 7 bits. So using that, tell me, if I have 3 characters here, when I convert this to binary, using the ASCII coding system, if I convert this to binary, my answer will have how many bits? Sorry, I guess there was a network glitch. I guess there was a small network glitch. Can you hear me now? Can you hear me? Okay, perfect. One, two, three, one, two, three. Okay, perfect. What do you call Y3 is because no, I was again change the network. The letter O is representing one character, slash is representing another character, L is representing another character. So these are the three characters. Is that clear? Fatima, got it? Okay, perfect. So that means if I convert this to what you call binary, if every character is going to be represented by 3 bits, I'll have a total of 21 bits. So even without converting the numbers, okay, even without the converting the numbers, I can easily tell that two answers here are wrong. What are the two answers that are wrong here? Option what and what? Without even doing any conversion, directly I can tell two answers are wrong. What and what? Exactly. So option 1 and option 2 has only 14 bits. So I can say definitely option 1 and option 2 is wrong. One shot. Now we have remaining two options, option 3 and option 4. Let's see, first of all, are there anything common between these two? If you look at option 3 and 4, in option 3, the middle value and option 4 middle value, they're exactly same. Option 3, option 4, middle value is the same. Only the right side and left side corner values are different. Okay. So without converting all three, that means without converting the letter O, the letter slash, and L, without converting all three to binary, let's first convert only one of them. So the question has said O is equal to, now we have two values, 79 and 111. Out of these two, which value should I take? 79 or 111? Perfect. I have to take 79. The reason is because in O level, they use capital O. So capital O's value is 79. So if I convert 79 to binary, I told you there's a shortcut. Okay. There is a shortcut. So what you do is you mention the first 7 bits place value. 1, 2, 4, 8, 16, 32, 64. These are the first 7 binary digits place value. So 1, 2, 3, 4, 5, 6, 7. There are 7 numbers here. Okay. So when you want to convert from ASCII, when you want to convert from decimal to binary, this is the easy method. Just write the decimal value and then front of that, just mention all the place values, the first 7 place values, and see to form the respective number, what are the digits or what are the values we are add together. Tell me out of these numbers I wrote in purple color, to get the number 79, what are the numbers I have to add together? 64 plus 8 is 72. 72 plus 4 is 76, 77, 78, 79. Yes. If I add these numbers together, I'll get 79. So below the numbers I need, I'm going to write 1. Below the numbers I don't need, I'm going to write 0. So value of O is basically 100 bubble 1. So 100, 4 ones. That's the option number 3. So without converting all the number, I can directly find option 3 is the answer. So this is how you can do this question faster without converting everything to ASCII. First of all, I know if there are 3 characters here, there has to be 21 bits. So from that, I remove option 1 and 2. Then I know the value of O has to come first. So I convert only O to binary. So once I convert O to binary, I got the answer as this. And then I saw which one has that first and I marked it correct. So that is how you do this question. So first of all, tell me out of 1, 2, 3, last week we did these two. So now I ask you to do these three questions now. So out of three, how many are correct? Okay, perfect. Actually, how many of you all did these remaining 4 questions? Raise a hand. Like these 2023 paper have 4 questions, right? No, actually, 5 questions. Roman number 3 as well. See how many they have done. Okay, I'll give you all around 1, 2, 3. I'll give you around 5 minutes. Do this question, all of you. So it's 8, 6, 2 now. At 6:10, I'll discuss the questions. 8 minutes I give you. Do all these 4 questions faster. Once done with these 5 questions, there's Roman number 3 here as well. So once you're done with all these 5 questions, raise your hand in Zoom. Sorry on the gap, guys. To the done, raise your hand up. You got extra time now, huh? No half is no. Is it half, sir? Enjoy. Oh, turn up your run. Where the gap is because I'm eating. I want. I'll check today. I can give you out like that. You come to the well out that I can give you. We all don't have no. No, no, I went to buy for the people here. So they basically, you know, there are some hardworking people here who are helping us with the watch day. So I want to give them something. So I got for all of them. And yeah, this is my share. If you all came, you also would have got it. Rizdan is there, so he also got. Mishafna is there. Zoha is there. All of them got. You come here, you. Okay, first question. He's in the, he has gone downstairs. I don't know why. He's not in this classroom. Okay, the first question is convert 216 to octal. If Rizdan is there, then can't trust that he'll go. So why you think he will not give you? Don't worry. If he doesn't give us, I'll give you. That's because Humera, Zoha came to some chess class. Like in the academy, they have started some chess class. No, that's why. Exactly. Yeah, well, Zoha is there here for the chess class only. If you don't trust me, you send anyone who comes to the class and ask. See in the poster at today at this time only this class also going. What to do, Zaina? They're small, no, they're kids. Zoha is around 5 years, I guess now. My kids are just 3 years. It's a talent alpha. Okay. To convert from any number system to octal, you divide by that number system's base. So to convert octal, you divide by octal's base. So octal's base is 8 no? So you divide by 8. 8 times 8, 16, 24. 8 times 2 is 16. 5 remains 53. So 8 times 5 is 40. 48. 48, 49, 50, 56. So I have here 53 now. So 8 times 5, 8 times 6. 8 times 6 is 48, 49, 50, 51, 52, 53. 5 remains. What are you doing? I'm doing calculation in my head. So this is how I do my calculations. Mind calculation. So divide 26 by 8, 8, 16, 24. 8 times 3 is 24, 2 remains. Divide 3 by 8, 8 times 0 is 0, 3 remains. Hmm? Isn't it 260 now? Oh, shoot. After I do all the calculations, I saw that. My bad. The question is saying 216. Sad life. I wasted so much time thinking. Okay, Zaira. Yeah, it's there in my hand. I'll finish the explanation and it. Yes, Haja. He has gone down though. I'm not going to believe your kids are three. That's because you have an extra data, Suraya. 216, eh? Okay. So if you divide 216 by 8, 8 times 2 is 16. 8 times 3 is 24. 8 times 2 is 16. 16 means 5 remains. 53 again. 8 times 26 is 48, 49, 50. Again, I'm writing 213. Why am I writing 213 like idiot? What do you call the? Yeah, then it's 8 times. What do you call 48 and 48, 49, 50. 56 is 27. Then 0 remains. Divide A by 8. 8 times 3 is 24, 25, 26, 27. 3 remains. Divide by 8. 8 times 0 is 0. 3 remains. Did you all get 330 as the answer? Perfect. Most of the sir like RH, his chai will come at least one time. Why is it not yours? Are they shy or you're scared? No, Hafsa, thing is my wife think that Kannur will come if you all see the kids. So, that's fine. But yes, Aisha. Correct, Suraya. Okay, next. Yeah, Amara. So, yeah, answer is 330. Next. Which of the following is the decimal equivalent of binary blah 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 blah? Okay, we have the binary as 1 0 0 0 1 0 0 0. So 1 0 0 0 1 0 0 0. And they are asking which of the following is a decimal equivalent. Okay. To convert from any number system to decimal also, it's a fixed step. What you do is you multiply every digit by its place value, right? So if I take the place value of the binary number, it's going to be 1, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7. So if I multiply every digit by its place value, 128 times 1 is 128, 64 times 0 is 0, 32 times 0 is 0, 16 times 0 is 0, 8 times 1 is 8, 4 times 0 is 0, 2 times 0 is 0, 1 times 1 by 0 is 0. Okay. After you multiply every digit by its place value, you find the sum of them. So it's going to be 128. I'm not including the zeros, but if I include the zeros, there'll be several zeros here. So 128 plus 8, that's 136. So answer is 130. Did you get 136 then? Do you watch football? I don't watch football, I play football. Next day, he say he's Ronaldo's long lost brother. I don't watch football, seriously. I only play football. 3-3, Amara. And it's rare. Sorry, Fatima. Do you like Messi or Ronaldo? I like Yusuf. So I said finals, then play for country. No time. Okay, so the answer is 136. Got that correct? Mark it correct. Put 1 mark there. Next. Hmm? I put everything in my mouth now. I can't speak. I gobble the whole thing at once because it's hard to put it. I'm not a human, I'm an alien. Which of the okay, now stop talking football and focus on the class. Which of the following is the hexadecimal equivalent of octal 1572 base 8? So they want to convert octal to hexa. Again, like we learned the previous question, from octal to hexa, you can't directly convert. No, Shada. What do you call understand, Padma? You can't convert directly or convert to binary. Exactly, Surya. Like if you all don't believe that I used to play football, I'll show you proof. It's there in my archives. Is during school time, right? It's out of the blur. Can't see the wave of the blanket for your information. That's one of the pictures. When I have a picture of the team. Yeah, okay, this is another picture. This is at Gateways a long time back. So you don't believe? I'll show later. The real picture. I used to play. I don't watch sports. Anyways, focus on the question. No, no, Hafiz, I'm not there. Yeah, that was me when I was a kid. Correct. Hmm. So chopped. Anyways, focus, all of you. At what age? That was probably when I was your age, when I was doing my O-levels. Okay, which is the following O-levels or L-levels? I'm not exactly sure. Which is the following is the hexadecimal equivalent of octal 1572 base 8? Okay, that was the question we started now. So to convert from octal to hexa, first of all, to convert to binary. Actually, there's a short way you could do this question as well. Focus, all of you. Now, when you convert 2 from what do you call octal and you convert this to binary, you get the number as 0, 1, 0. Okay, you get the number 0, 1, 0. When you convert 7 to binary, you get the answer as triple 1. Okay, if you're wondering which method I'll be using, that same method I used in the previous question. Okay, if I use this method, this is what I wrote in green and blue. I'm not repeating it. But if you look at this question, this method here, using this method, if I find the value of 7 and 2, I'll get 7 is equal to triple 1 and 2 is equal to 0, 1, 0. Now, you know what you should do is, first of all, you might convert all of them to binary and put them together. And then after you put them together, you're going to group them into 4 bits by 4 bits. That's how the method works. No? So without converting everything, what I did here is I'm going to convert only 2 digits. See, I convert only 2 digits to binary. And after I convert to binary, I know how hexa works now. How hexa works, we take 4 bits as 1 digit. So if I take these 4 bits, that is 1010, and if I convert 1010 from binary, if I convert that to hexa, what's the value? The value is going to be 8 plus 2, that is 10. So now I know in my final answer, the last character is going to be A. So if I go through the answers given here, only one value has A. So this is the fastest way of doing MCQ. Is that clear, all of you? Did you understand how I did it? I did it a bit faster, but did you understand without converting the whole number how I did? Okay. So those who did not understand, I'll again explain. Listen properly. Yeah? Those who did not understand, I'll again explain. Listen. Now the usual normal method, what I might do is, I might first of all find what are the 3 bits hiding behind all the digits. Okay. To do that, I have the 124 method. No, so 124, 124, 124. I will circle the numbers I need to form the respective digit. To form 0, I need only 1. To form 5, I need 4 and 1. To form 7, I need 4 and 2 and 1. To form 2, I need 2. So I circle the numbers I need. Below the numbers I need, I write 1. Below the numbers I don't need, I write 0. And then I join them together. I have a final answer as 001, 101, 111, 010. These are normal method, no, how I convert to binary. And after I convert to binary, the next step what I would do is I would group these 4 bits as 1 digit. And I would group these 4 bits as 1 digit. I would group these 4 bits as 1 digit, 0011. And then I might convert them to what do you call from hex, from binary, I might convert them to hexagonal. So during that process, I normally did 1 to 4 it, 1 to 4 it. Wherever 0 is, I cut the place value. I write the sum of the remaining. These are normal method, no? How I find the answer. These are normal method, how I find. So without doing so much of steps, what I did was I just took the last two digits, 7 and 2. I converted, first thing I did is I converted 7 and 2 to binary. Is that part clear? Tell me first, Humera. Sorry. Perfect. I converted the last two values to binary first. Now, when I put these numbers together, this was a binary number I got, no, 111 010. Now, after I convert 5 and 1, I'll have three more digits for 5 and three more digits for 1, right? After 1 and 5, I have a longer digit now. Okay. So without converting that, for now, I'm just going to convert only this much and stop from here. And I know that after I do this, the next step I have is I have to break this whole binary into 4 bits by 4 bits now. Okay, that's what we did here, right? After you find the full binary answer, we have to break it into 4 bits. So without waiting till I find the full binary, as soon as I got 4 bits, I'll first of all take the right side 4 bits. So my right side 4 bits are 1010. Is that part clear? Now I might find what is that one digit representing these 4 bits. So if I convert 1010, if I convert that 1010 into, actually this process is called this binary decimal conversion. But anyways, if I find the hexadecimal digit of 1010, I get there. If I do this 1248 method, I get the value there as 10, it is equal to A. Is that part clear? Like this process. So now what it is, I came and saw the answers I have here. Out of the answers I have here, only in one answer, the last digit is A. The remaining answer, we don't have A in the right side corner. So that's why I know the remaining answers are wrong and is the correct answer. Make sense? So this is how you can save time. Depending on the question. So depending on the question, sometimes there could be two answers with A. So then you have to do one more step extra. So it always depends on the question. Always in MCQs, you have to play a bit smart because you can't waste time in MCQs. So as much as possible, you have to reduce the time waste. Make sense? Okay, next. 1 TB is equal to how much? Number conversion, you can see in everything they have given you the answers in KB. So we have to see what is the KB answer. If you all can remember, I told you a shorter method to remember the units. What is it? Remember the order of the units. I told you a shorter method. What was it? Yes, the big brother method. Big brother can made green to purple. So now what you can do is the question they have given the value in 1 TB. Okay. Good. So 1 TB. We have to convert this 1 TB to KB. So here is where TB is there. We have to convert TB to KB. That means we are going to go one step, two step, and three steps up. Now, if you can remember, I told you a way to remember of how to remember the multiplication division part, right? I told you in a company, when you go up, your salary gets multiplied. In a company, when you go down, your salary gets divided, right? So that means for each step, when you're going up here, I have to multiply. Okay, multiply, multiply, multiply. For every step, I have to multiply, right? Whenever the word bit is there, okay, whenever the word bit is used, you multiply or else divide by 8. But for others, how much we use? Done? In that paper, just mark what you all are done and send a picture of that in the group. They've cut. M is not done. There was yesterday two groups were doing. One group was doing C, one group was doing M. So that's why C is like almost done and M is not still done. Whatever is done, just mark and keep. So then on Tuesday we can continue the balance. Thank you. Sorry in the gap. So what do you call for others, how much you should use? When the word bit is there, we use 8. For others, how much we use? In a few minutes, so the last question. Perfect. For others, we use 1024. So to convert from TB to GB, we will multiply by 1024. To convert from GB to MB, we will multiply by 1024. To convert from MB to KB, we will multiply by 1024. So that means if you want to convert 1 TB to KB, first of all, to convert to GB, no? So to convert to GB, you multiply by 1024. And then the GB answer to convert to MB, again you multiply by 1024. And to convert the MB answer back to KB, we again multiply by 1024. So that means 1 TB, when you convert to KB, the value will be 1 times 1024 into 1024 into 1024. Is this part clear, all of you? After a while, so I'll do. I'll just check the name, I'll wait. So if you check your answer here, 1024 into 1024 into 1024, the answer is option number 3. So if you got this correct, mark it correct, put 1 mark there. If you have any questions, drop in the chat. Then, the last question. Yeah, exactly, Amara. Convert 85 base 10 to its binary equivalent. Again, from decimal to any other number systems, you divide by that number system's base. So binary decimal to binary, you divide by binary's base. So 2 times 42 is 84, 1 remains. 2 times 21 is 42, 0 remains. 2 times 10 is 20, 1 remains. 2 times 5 is 10, 0 remain. 2 times 2 is 4, 1 remain. 2 times 1 is 2, 0 remain. 2 times 0 is 0, 1 remain. So you keep on dividing until you get 0. After you get 0, you write the remainders from bottom to top. So answer is going to be 101, 01, 01 base 2. If you got this correct, mark it correct, put 1 mark. So if you have any questions, drop in the chat. Others tell me out of 5 marks, how many marks you got? Good, good, good. Okay, perfect. Those who have any questions, or can stay and ask. Others, if you don't have any questions, I can leave. We're done for the day. So shall I do that in this one? On Tuesday itself advance, because I can give you this question to do in the class. This one I saw the question. It's a full question. No? Take it in the class to do. What if they give the binary value? As in, you're welcome. Bye bye. Hana, what do you mean by that? Welcome, Shana. Can you explain shortcut method used for the eighth question? Yes, sure. What I did was basically, all are you clear that in general when you're converting, you have to convert the whole number first of all to binary, and then the binary answer you have to break it into 4 bits by 4 bits. Is that part clear? The normal method. Okay. So what I did here is without converting the full number to binary. Okay. Now the full number is where you have to convert 157 to see. I converted 157 to I converted all the numbers to what do you call the bits, and that's how I formed the binary now. So without completely forming the binary number, I first of all converted only 2 and 7 to binary. So when I converted only 2 and 7, I got only these 111 and 101 value. Is that part clear? Without converting the full thing to binary, I took only 2 digits. I converted only 2 digits. And then when I converted 2 digits, I got 6 bits no. Right. So I know that at the end of the day, by why only at least 2? Because for it to form a hexadecimal number, okay, to form a hexadecimal number, 1 digit requires how many bits? Hexadecimal number system where 1 digit represents how many bits? No. In hexadecimal, now behind the number 7, how many bits are there? Behind number 3, how many bits are there? Behind the letter A, how many bits are there? It represent how many bits? How many binary digits it's hiding? It's 4. Okay. So if I convert only 1 digit, I get only 3 bits. So using bits, I can't find the equivalent hexadecimal. To find hexadecimal, I need 4 bits. So in order to get 4 bits only, I had to convert 2 numbers. Make sense? So after I convert 2 numbers, now I can take 4 bits. So then what I did is, without converting the full number, I just took only the first 4 bits and converted only that to binary. So only that to, I found the hexadecimal digit equivalent to that value. So after I found the hexadecimal value equivalent, I just saw only one answer had A, the remaining answer did not have any values. Does that make sense, Ala? Any questions asked? He's not in this classroom, Fatima. Might be in the next one. Welcome. Bye. Okay. Surya done. Sorry, I think I sent the wrong one. Wait. Okay, sent. Ah, yeah, if you can let me know, Shazana. Can you apply that every time? Every time you can apply that, but that doesn't mean all the situations will come favor to you. So sometimes there could be two questions with A in the right side corner. So then you have to find the next digit as well. So it depends on the question. But you can start like that. First see the right side corner digit, then see the second digit. Like you can go step by step. Make sense? Shazan, what was the question? Okay, Fatima. Okay, just give me 5 minutes. I'll quickly play and come, and then I'll discuss this. Even you all can go and play and come. So it's 6:41 now, at around 6:46, 6:47. I'll continue. Okay. Is that fine, Fatima? Okay, perfect. So at around 6:40, between 6:45 to 6:50, I'll be back. And I'll start, okay? Others, if you all want, I can just try doing this question as well. I'll be back. Shazana, send me a question in the chat. I'll pray and come and check, okay? Okay, Fatima, back. Okay, give me a moment. We'll start. Wait. Okay, sorry on the gap, Fatima. Yeah, we can, we can. So the question says, what do you call a security system is activated in a modern motor vehicle? In modern motor vehicles, an electric bell rings when the door is open. Electric bell rings, it seems, when the door is opened without using the key and the door of the driver's side is open. Which of the following logic gate circuit is the most suitable for practical use of open door using the key as zero? Practical use of open the door using the key as zero, and if it's not as one, when the open the door in the driver's side is one, when open the door in the driver's side is one, if it's not as zero, ringing the bell as one, it's okay, fine. So first thing they have mentioned here is there's a electric alarm, and that will ring when the door is open without the key and the door of the driver's side is open. Okay. So there are two things. One is door is open without the key, and second thing is the door of the driver's side is open. The door of the driver's side is open. So they have said which of the following logic gate circuit is the most suitable for practical use of open the door using the key as zero, and if it's not as one. Okay, so they are saying now we have two things we're going to check. One is T and one is Q. T is basically where we're going to check open the door without using the key. This is open the driver's side. Okay. So there are two things that is check. T is checking whether the door is opened using key. Door opened without key. That's what T is checking. Without key. And Q is checking is the driver's side open. Q is checking is the driver's side open. And then next in this question, they have mentioned here that uh, if the door is opened using the key as zero and if it's not as one, okay. So if the door is open using the key, consider that as zero, and if it's not as one, okay. So that means we have zero and one now. So one means without the key, the door is open without key, and zero means the door is open using the key. I got that point from here. So they have mentioned there has to be a comma here. The sentence is not broken properly. This is probably a translated paper. So when translating, they don't made it properly. So because the correct sentence should be for practical use, and then it has to be when the door is open using the key. So consider the door open using the key as zero, and if it's not as one. So the door open using the key as zero, without the key as one. Up to here, tell me, did you understand what I did, Fatima? I saw that there are two things we're going to check, T and Q. T means this, Q means this. When T is 0, this is the meaning. When T is 1, this is the meaning. Up to here, does it make sense? Yes or no, Fatima? Surya, can you wait then in that situation? Okay, fine. Then, because as I asked earlier, then if you take Q, Q is going to check is the door open in the driver's side? No. When you continue reading the question, they have mentioned when the open the when the door is open. See, the English is not proper here, but the correct sentence should be when the door is open in the driver's side as one, and if it's not as zero. So zero means is not opened. The driver's side is not open, and one means the driver's side is opened. Okay, so the English is not proper, but if you're going to correct the English, it would have been something like this. So consider when the driver's side is open as one, and if it's not as zero, something like that it has to be. Is that part clear? Okay. So now for the alarm to ring, what is our expectation? In this part, the blue color underline part, I have mentioned when will the alarm ring? So based on that, tell me for the alarm to ring, what is our expectation from T? Do we want T to give us zero or do we want T to give us one? What is our expectation from T? Exactly. See, no. The question is saying when the door is opened without using the key, the alarm will ring. So without the key means T is going to give us zero or T is going to give us one. We want alarm should ring when the T is one. Exactly. Alarm will ring when T is one. Sorry. What about Q? Will alarm ring when Q is zero or when Q is one? Correct. When Q is one. So has a question told that when either one of the conditions are true, the alarm will ring, or when both of these are true, the alarm will ring? Both or either? Both. See, I use the word called and. So the actual gate would look something like this: T, Q, and both of them going through the AND gate. That's how the actual gate would be. But if you look at the answers given here, have they given an answer like that? So I think this has to be Q, 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 Q. Have they given an answer that? Have they given an answer like this? No. So we have to go to the remaining three options and see, is there any of the gates here that will act like this? Okay. Now you know how the AND gate works, right? How the AND gate works. AND gate will go and check the input, and AND gate will give you the output as one. In which situation? When will AND gate give you the output as one? When? When what is one? If you take AND gate will give the output as one. In which situation? When what is one? Correct. AND gate will give the output one when all the inputs are one. So if all the inputs are one, output is one. If all the input is one, then in the AND gate, output is one. That's how the AND gate works now. So we have to see out of the three answers, which answer will work in that kind of a way. Now tell me for the AND gate, if the value of T was one and if the value of Q was zero, what do you think the result of the AND gate would be? Maybe, Shadana. Correct. The result will be 0. So first of all, let's see out of the remaining four options, what will give you 0 as a result? Huh? Let's say Q is 1 and T is 0. What is the name of this gate they have used here? So it's like a OR gate. The OR gate is a circle in front. How do you call this gate? OR gate is a circle in front. What do you call this gate? Correct. This is called the NOR gate. So you know NOR gate how it works, right? NOR gate gives you the opposite of OR gate. NOR gate gives you the opposite of OR gate. So first of all, tell me for an OR gate, if one of the input is 1, other input is 0. No, it is OR because it's like a, see, this is NAND gate. NAND gate is straight. NOR gate is curved. Got it? If it's curved and a circle in front, it's no. If it's straight and a circle in front, that's NAND. Got it? Perfect. Now, NOR gate is basically the opposite of OR gate. No? NOR gate is actually the opposite of OR gate. So OR gate will go and check is any of the input, right? Is any of the inputs 1? Yes. So OR gate's result will be 1. If OR gate is going to give you 1, then NOR gate will give you 0. If OR gate is going to give you 1, then NOR gate will give you 0. Okay, so that means in this situation, it's correct. Okay, in this situation, it's correct. So let's see in different situation. For example, if both the inputs are 1, if T is 1, if Q is 1, if both the inputs are 1, what is our expected result? In the correct situation, if both the inputs are 1, how should the output be? Correct. In the AND gate, it should be 1. Let's see how it will work here. Tell me, in the NOR gate, if both the inputs are 1, what do you think the result of the NOR gate would be? For a NOR gate, if both the results inputs are 1, what will be the result? Perfect. Because NOR gate is opposite of OR gate. In OR gate, if both the inputs are 1, output is 1. So opposite of OR is 0. So that means, can the first diagram be correct? No, because in our expectation is this. These are the expectation. So therefore, first diagram is wrong. So now you go for the second diagram and check. Actually, second diagram, before going for the second diagram, I'll go for the third and fourth, okay? In the third diagram, if both the inputs are 1 here, after it pass the NOT gate, both will be 0. If both be zeros, if both these zeros goes to the OR gate, what will be the result of the OR gate? 0. Is that matching our requirement? Again, no. Let's say if both the inputs are 0, if these, sorry, both the inputs are 1, same situation. Huh? If both the inputs are 1, if both inputs goes to NOT gate, it will become 0 here and this will become 0 here. If both these zeros goes to the AND gate, what will be the result? 0. So that means, is this last one again matching with us? No. Now let's take the remaining one. Is this matching? Here I'm going to take QS1, sorry, QS1, TS1. If both of them are 1, once this 1 goes to the NOT gate, this one becomes 0. Okay. So now we have a NAND gate here. For the NAND gate, one of the input is 1, other input is 0. First of all, tell me, for an AND gate, if one of the input is 1, other input is 0, what will be the result of the AND gate? 0. So if AND gate gives you 0, then NAND gate should give you how much? 1. So in this situation, we can see NAND gate, that diagram given there, it's matching with our requirement. But let's see the different situation. Huh? Let's see a different situation. For example, where T is 1 and Q is 0. Let's say we have a situation where T is 1. Okay, let's say we have a situation where T is 1 and Q is 0. Now, if t is 1 and if q is 0, our expected result is what? If t is 1 and q is 0, our expecting result is what? We can, if you use your check, it should know. Basically, it should match in all the situation. How does AND gate work? AND gate works like this. If you take AND gate, if you take t and q and output, if both are 0, output has to be 0. In AND gate, this is how it works, no? This is how the AND gate's truth table work. So we have to check which gate for matches all four. Only if all four matches, then we can say, okay, that's equal to AND gate. Even if one of them fails, we can say it's completely failed. So in the remaining three, we saw some errors were there. At least one row did not work. So at least if one row doesn't work, we ditch them all. Make sense? Hmm. So now, if t was 1, if q was 0, our expected result is what? Perfect. Expected result is 0. So let's see, is that what we're getting here as well? If t was 1 and if q was, so if q was 1, so q was 0 and t is 1, no? My bad. If q was 0 and t was 1. If this 1 goes to the NOT gate, the 1 will become 0. If both these 0 goes to the AND gate, what will be the result of AND gate? 0. Then if it goes to the NAND gate, NAND gate is the opposite of AND gate. So AND gate has to be, are we getting 1? Is 1 our expected results? No. So that means this question is wrong. There is no correct answer in this question. Open the door using key as 0. Open the door using key as 0. And if it's not as 1, so without the key as 1. Then open the door in the driver's side as 1. Open the door, and when open the door in the driver's side, open the door in driver's side as 1 and not as 0. So alarm should ring when the door is open without using the key. So that means T has to be 1 and door of the driver's side is open. Question is wrong. Any of these answers are not matching. What paper is this? So normally how you do these kind of questions, you start with this. First of all, you start figuring out what are the inputs we have. Okay. That is T and Q. After you figure out what are the inputs there, the second step is going to be figure out, as per the question, what do they mean as T being 0, T being 1. For every input, figure out what is the meaning of 0, what is the meaning of 1, what is the meaning of 0, what is the meaning of 1. Every input you need to figure out that. That's step number 2. Is this part clear? Step number 1, figuring out all the inputs. Step number 2, figure out the meaning of 0 and 1 of those inputs. Is that part clear? The order. Yeah. Then step 3, you see, okay, for the circuit to work, that means, in this circuit, what are we building? We're building alarm. So step 3 is basically for the alarm to work, see what is our expectation from every input. So for the alarm to work, the question is saying the alarm rings when the door is open without using the key and the door of the driver side is open. So that means the door has to be open without the key. Okay. Bye. Thank you for coming. So the door has to be open without the key and the driver side has to be open. Okay. So that is why I circle these two. So step 3 is figure out what is our expectation from T, what is our expectation from Q for the alarm to work. That's step number 3. And step number 4 is figure out how will the alarm ring. The question is saying the alarm will ring when the door is open without the key. That means when T is 1, okay, the alarm will ring when door is open without the key. Sorry, T is 1. So so normally if you want a letter to be 0, we consider the dash version of it. So we consider this as T dash, this as T. If you want Q to be 0, that means we consider that as Q dash. If you want Q to be 1, we consider it as Q. Okay. So for the alarm to ring, our expectation is the door has to be open without the key. That means we want T to be T. And the question is said without using the key and. So and is represented using dot no. and the door of the driver's side is open. So door of the driver's side is open means we want Q to be 1. So this is our expectation. Okay. So normally by reading the paragraph, you should be able to figure out the Boolean expression. And then using that Boolean expression, you should draw the diagram. That's how normally we handle logic gate questions. First, figure out what are the inputs. Second, figure out what is the meaning of zero in one of those inputs. Third, circle what are our requirements from zero. So what are our requirements from every input? Using the paragraph, form the Boolean expression. Step 4, convert the Boolean expression to logic gates. This pattern will work for any logic gate question. But that's the way you have to handle logic gate questions. Make sense? Yeah, when we still start logic gate questions, no, that you once we start logic gate questions, it will make sense. But I think this question has to be something like the alarm has to ring when the door is open without the key and the door of the driver's side is closed. Okay. It has to be when the door of the driver's side is closed because it doesn't make sense, right? When the driver's side is open, what's going to happen by using the key and opening the door? It doesn't make sense. So I feel that the question has to be when the door of the driver's side is closed. Then I think you might get a diagram that's matching. I don't know. I feel like that has to be how the question is. But anyway, double check with the marking scheme. Is there any errors in the question? Because there's no answers matching. Got it? Next, which of the following logic gates are equivalent to each other? So how you check are they equal is you just take random values for x and y. Random values as in ones and zeros. Okay. So for example purpose, what I can do is I can take both of them, let's say same value or both of them different value. Anything you can take out of these combinations, you can choose, you can start with any combination. So for example, if I take the value of x and y as 0 and 0, when this 0 goes to the NOT gate, 0 will become 1. When this 0 goes to this NOT gate, this will become 1. And when both the ones goes to the AND gate, 1 and 1 will be 1. Now let me try it for the remaining gates as well. Here, if both of them are 0, when both these 0 goes through the NOT gate, 0 will become 1. When it goes to the NOT gate, 0 will become 1. When both the 1 goes to the OR gate, it will be 1. When x and y both goes to the 0 AND gate, 0 and 0 will give you 0. When 0 goes to the AND gate, it will become 0. When the 0 goes to the NOT gate, it will become 1. When 0 and 0 goes to the OR gate, 0 and 0 of OR gate will be 0. When it goes to the NOR gate, it will become 1. Okay. So when I use x and y as both same values, everyone gave the same output. But just because everyone is the same output, you can't tell all of them are same. You have to double check with the remaining values as well. So let me try a different combination. Let me try a different combination. Here in this combination, all of them give same values. So let me try with a different combination. What I'm going to do is I'm going to take the value of x as, let's say 0, y as 1. When x is 0, 0 goes to the NOT gate, 0 becomes 1. When 1 goes to the NOT gate, 1 becomes 0. When 1 and 0 goes to the AND gate, the result is going to be what? 0. Now here, if we have 0 and 1, when 0 goes through the NOT gate, 0 will become 1. When 1 goes to the NOT gate, 1 will become 0. When 1 and 0 goes to the OR gate, what will be the result of the OR gate? 1. Now similarly, when 0 and 1 goes to the AND gate, what will be the result of the AND gate? 0. When this 0 goes through the NOT gate, what will be the result of the NOT gate? 1. Now, when 0 and 1 goes through the NOR gate, first of all, before going for NOR gate, tell me if it goes to the OR gate, what will be the result? 1. So if it augurs, if it goes, if it's 1, then NOR gates result has to be 0. Okay. Now based on this, tell me, is A and D having equal values? A and D? Yes. Are B and C having equivalent values? Correct. Okay, so that one looks correct, but let's go through other answers as well. The second answer they have said B and D are equal. Are B and D equal? No. So we definitely know this answer is wrong. Are all of the above equal? Are all of them equal to each other? Like when I give the same input for everyone, did we get the same output in all the situations? When I gave X and Y as the same input for all of them, did everyone give me the same output? All four of them the same exact output? Input is same. For everyone I have given X as 0. For everyone I have given Y as 1, right? When I give the same input for everyone, was my output same from all four gates? For example, X is 0, Y is 1. When X is 0 and Y is 1, is output in all the gates same? Why are you asking that the question mark, man? Are all these four numbers same here? Or can you see the numbers for here, output for here same? Yes or no? Confident, tell me. Like look and see, man. No, in the first one it was the same. Ne? That's why I said it has to. So if you want to tell that two circuits are same, if you want to tell that two circuits are same, in all the situations it has to match, not only one situation. Makes sense? To tell two situations are same, it has to match in all situations. If it fails, at least even in one situation it fails, like no, it's not matching. Okay, so tell me when X and Y were the same input, was output same in all four? It has to be same in all the situations, not one situation. Was it same in all the situations? When output is same, input is same, is output same? No. So that means this is also wrong. Third option is saying A and B are same. Is A and B same? No. So now we know that definitely two. Now we have justification for why 2, 3, 4 is wrong. So based on that, we can do first is correct. But if you want to do like if you want to be double sure, you can check the remaining situations as well. Now for in this example, I checked where X and Y both were 0. In this example purpose, I checked when both X and Y was 0. X was 0, Y was 0. I checked this situation. The next situation I checked was where X was 0 and Y was 1. But if you want to be 100% sure, you can check the remaining situation as well. The remaining situation is where X is 1 and Y is 1. Apart from that, the other situation is where X is 1 and Y is 0. So if you want to be 100% correct, you can double check these two as well. Got it? So you can tell two circuits are exactly same. I put the fourth one. Do you understand why the fourth one is wrong? Because all four circuits are not the same. You can't just depend only in one situation. You have to check to tell exactly all are same. You have to check all three situations. Now here I did not check all three because I already found that three answers are wrong already. Because when you find one answer is wrong, then definitely the balance is going to be correct in such questions. But if you want to make double assurance, you can check the remaining two as well. But first of all, tell me, Fatima, are you clear why the fourth answer is wrong? Hmm? Do you have any questions? Do you have any questions? Do you have any clarifications asked? Still, it's I'll tell you one thing. Listen. Simple question. Are these two exactly same? You have three answers. Yes, no, I don't know. Can choose one. How do you know it's same? Like, how do you prove it's same? How do you prove two circuits are same? So basically, there's a way how you prove it's same as well. Look at this, okay? So for example, why can't I click on anything? Give me a moment, I'm in the charging. One second, wait. So how you what you call prove whether it's same is basically you have to prove using truth table. That is, as per truth table, if you look at this gate, if A and B, okay, if you draw the truth table for this, the truth table would look something like this. I'm just drawing the truth table faster. If I draw the truth table for the NAND gate, it look like this. Zero times if zero and zero for AND gate it will be zero, NAND gate one. Zero and one for the AND gate will be zero, NAND gate one. One and zero for AND gate will be zero, NAND gate one. One and one for AND gate one, NAND gate zero. This is the truth table for the NAND gate. If I draw the truth table for this A and B, 0, 0, 1, 0, sorry, 0, 0, 0, 1, 1, 0, 1, 1. OR gate. If 0 and 0 goes, it will become 1 and 1. When 1 and 1 goes, result will be 1. When 0 and 1, when 0 and 1 goes, 1 and 0. 1 and 0 is 1, opposite of 1 is 0. 0 and 1 goes is 1 and 0 goes. So if 1 and 0, 1 and 0 is 1, opposite of 1 is 0. When 1 and 0 goes, when 1 and 0 goes, it's going to be 0 and 1. When 0 and 1 goes, 0 and 1 is 1. 1 opposite of 1 is 0. When 1 and 1 goes, it becomes 0 and 0. When 0 and 0 goes, 0. Okay. I drew the truth table faster because the truth table is the main point I want to show you all. But if you look at the circuit, when I drew the truth table for both of them, a truth table has multiple rows, right? Every row defines a situation. Okay. Now compare all and tell me In all the situations, are both of them matching? In the NAND or first one is X or Y? In which circuit? In Y. Okay. So third one is 1 and 0, no? When A is 1 and B is 0. That's the third situation, correct? That's the third situation, right? A is 1. Yes. So when a 1 goes to the NOT gate, what will the 1 become? When 1 goes through the NOT gate, 1 will become 0. Wait, I made a mistake here. When 0 goes through the NOT gate, 0 will become. But when both of them goes to the OR gate, the result will be 1. I made a mistake. These two has to be 1. Okay. So what do you call when I draw the truth table, you compare both the no, if you read the truth table, every row represents a situation. So if you want to tell if both of them are equal, you'll compare both every row. Okay, that means when A is 0, B is 0, here we got 1. We have to check, okay, here also are we getting 1? So likewise, if you compare all the rows, is everything matching? Is everything matching? Is all the rows matching correctly in both the tables? Yeah. So then we can tell, yes, both of them are equal. People ask, right, isn't A plus B whole thing dash? People ask, right, isn't A plus B whole thing dash equal to A dash plus B, A dash dot B dash? It's actually wrong. A dot B whole thing dash. See, after you draw the truth table, you can say A dot B whole thing dash is equal to A dash plus B dash. Okay, so you can prove that these two are not equal also using truth table. If you draw a truth table for these two, that is A dot B whole thing dash. If you draw a truth table for this, and if you draw a truth table for this, A dash dot B dash. If you draw these two truth table, you will see they're not equal. So for you to tell two circuits, and for example, draw the truth table and show you. Okay, for these two, I'll draw the truth table A and B, and let's take P and Q here. So 0, 0, 0, 1, 1, 0, 1, 1. Here it's going to be 1, 1, 1, 0. Here it's going to be A, B, Q, 0, 0, 0, 1, 1, 0, 1, 1. And here A and B are going to be 1 and 1. 1 and 1 is 1. Then here 1 and 1 is going to be 0 and 0. 0 and 0 is 0. So 0 and 1. When 0 and 1 goes, it's going to be 1 and 0. 1 and 0 is 0. 1 and 0 becomes 0 and 1. When 0 and 1 goes, it's going to be 0. Okay. I did it fast in the mind, but slowly if you do the truth table, this is how the truth table for the second circuit you get. Now, when you compare both these circuit, you can see there are four situations, right? Are all four situations matching in both the circuits? Are all the four situations? No. How many situations are matching? In how many situations both of them will act the same? Exactly. See, two situations, both of them will act the same. But just because both of them are acting only in two situations, can we tell both are exactly the same? No. So for you to tell both are exactly the same, in all the situations, it has to act same. So you can say these two circuit in all the situations acted the same. So therefore, these two we can say it's equal. These two are not equal. So for you to tell two things are equal, it has to match in all the situations. Even in one situation, if it doesn't match, even in a single situation, if it doesn't match, then using this as a proof, we can say because of this, we can tell it's not matching. It's not the same. Even if one doesn't match, we can tell it's not the same. Got it? But the gate is NAND and NOR. No? How are they same? Because you see the number of gates used. So there's a way you have to arrange the gate. If you do LOL logic gates, you will be learning this as a rule. This rule is called, is this rule De Morgan's law? I think this is De Morgan's law. Yeah, this is called De Morgan's law. You might sometimes Rizal answer might slightly mention about this in what do you call sets lesson. This has a small connection to sets, but this is a rule you learn in LOL ICT. But what you called you can form one gate. You can form equal circuits in different way of arrangements. See, even though they are, I have used here NAND gate and here is OR gate. It's not only OR gate. Here I use NOT gate and OR gate. It's not, it's NOR gate is like this. NOR gate is where after the OR gate you have the NOT gate. So if you try to compare NOR gate and NAND gate, it won't be same. So this is not NOR gate. Huh? For it to be NOR gate, it has to be something like this. Makes sense? Yeah, Hannah. Why isn't it NOR gate? Because NOR gate is this. This is what we call NOR gate. OR gate result going to the NOT gate. This is what we call as NOR gate. Does it look the same? Is this cell one I have drawn here? Are these looking the same? So this is what we call as NOR gate. NOR gate is where NOT gate is there after the OR gate, not before. So this is not called NOR gate. This is a separate circuit. This is a standalone circuit. Okay, Shazan, no issues. There is no single name for that gate. By the way, this is not called NOR gate. Huh? This is not called NOR gate. This is equal to NOR gate. This is what you call NOR gate. This is what you call as NOR gate. This is NOR. This is equal to NOR. Got it? NOR gate is formed by combining OR gate and NOT gate together. Is that clear? So you don't this no this doesn't have a name. This is a circuit. A circuit has a collection of things used together. Now, for example, if I show you a circuit, circuit will have a collection of gates. So this is not one gate. Look at this. If you take this diagram, they're not one gate. We don't have one name for this. This is called a circuit. We have a collection of gates used. So we don't call this as one name. We call this whole thing as a circuit. Make sense? So in this circuit, I have used a NOT gate, OR gate, AND gate, and OR gate. So likewise, in this circuit, I use a NOT gate, and OR gate. In this circuit, I have used OR gate and NOT gate. Clear? Fatima, got the idea? So you want to say if two circuits are same, in all the situation test match. Even in one situation, if it fails, then you can't say it's same. So how you reject this, even in a single situation, even if it doesn't match, like it is not same. You do more questions, you'll understand the idea. If you have a doubt in your head, phrase your doubt as a question and ask. Sorry. Okay, you do more questions and just apply the idea I told you. And then when you come across any issues, let me know. Okay, Fatima. That means that class already started. Sad life. What is the subject? Nice. Enjoy. What is it? You called? I'll come with. Enjoy, enjoy. What? I'll come. Give me a moment. I'll come with. Are there any questions with you? Okay. Fatima, I don't know if you have any other questions. You have any clear? Done. Okay. So I come to your question now. So give me one moment. I just saw that in a couple. Give me one moment. Let me first of all take your question, download your question. Yeah, so give me a moment. I'll come. Bye bye. Barakallah. Sorry, Suraya. I recalled there was developers going and they were leaving now. So I had to settle it down. You're here, right? Okay, let's start. So the question says the following Pascal users to end. You want to do the question A and B both, right? Sorry. A and B both, right? Okay, perfect. The following Pascal program uses to enter five student subject marks and calculate the total and display it. Okay, fine. Answer following questions according to the above Pascal program. How many elements contains of the array? Right. If you go to the program, the first line will define the name of the program. And second, we have the word called var, right? After the word called var, these two lines are there, right? This part is something called as variable declaration. This portion we call it as variable declaration. Variable declaration. So if you take array, array is actually a type of variable. The main difference between a variable and an array is that a variable can store only one value at a given time. Array is a variable that can store multiple values under the same name. So if you have a name called x, x can store only 5. But if you have array call x can store, let's say 2, 1, 3, it can store multiple values. Okay. Yeah, sure. Okay, that's the difference between a variable and an array. So if you look at the variable declaration part, you can see they have declared a variable called I, they have declared a variable called total as integer. So variable declaration is you mention the names of the variables and you mention their respective data type. So we have two variables here, I and total. But if you look at the variable declaration done for marks, without directly saying marks is an integer, we also say marks is not a normal variable. Marks is actually an array that has index from 0 to 4. So 0 to 4 is talking about the range of index, which means there's an array called marks. And this marks array has index of 0, 1, 2, 3, and 4. Is that part clear? If you take I means I is one box. If you take total, total is one box. Those are variables. Variable can store only one value. But if you take arrays, they can store multiple values. So first question is asking how many elements contains of the array. So basically every value called value the array can store, we can call it as an element. Okay, every value we can store is called element. So the array called marks can store 1, 2, 3, 4, 5 elements. So answer is yes, 5. Is that clear? Sorry. Okay. That is clear, right? Okay. Second question, what is the data type of the array? So you can see the end of the statement, we have mentioned the data type of the array. That is integer. At the last, we mentioned the data type of the integer after the word call of. That's mentioned here. The third question is asking what is the name of the array? So what is the name of this array? What is the name of the array? Now the name of this variable is I. The name of this variable is total. So tot. What is the name of that array? The name of the program is this one. This is the name of the program. What is the name of the array? No. Just like how I is the name of the variable, just like how total is the name of the variable, what is the name of this array? Nope. It's marks. Marks is the name of the array. Is that clear? Okay, so name of the array is marks. The next question is saying, show how the array will display when entering the marks as 60, 90, 82, 45, and 92 respectively. Okay, let's see. So how the program works is, in the program we are saying total equals 0. So let's draw the dry run below when the program is running. Where is that mentioned? Here. See, here marks, variable marks array. Here. Hmm. Okay, so the program is starting. We have a variable called total, and total is equal to 0. Apart from that, we have a variable called I as well. Okay, so when the program started, total was 0. So I'm going to mention a total as 0. Next, we have for I equals 4 down to 0. So when the program started, the first value of I was 4, right? And how for loop works is you have a starting value, here ending value. So for loop, there are two types of for loop. One is for to do loop, another one is for down to loop. In for to do loop, we go from a smaller number to a bigger number, like this, 2 to 4. In for down to loop, we go from a larger number to a smaller number, something like this. So for down to, what happens is automatically the value of the variable reduces. In for to do loop, automatically the value of the variable increases. So for to do loop, automatically it increases. In for down to loop, automatically it decreases. Is that clear? Okay. So the program is running. They have mentioned here for I equals 4. So value of I is 4. Begin. Write ln enter marks. So we're asking the user to enter the marks. Then read ln marks. So read ln marks, it will store the marks the user entered. Okay. What is the, as per the question, what are the first marks the user is entering? 60. Okay. So that means in the array called marks, index I. So when you say index I, we will replace I with I's value. What is the value of I at the moment? Sorry. What is the value of I? Look at the table. Perfect. I is 40. So in the array called marks, index number 4, sorry, not 44, index number 4, the value is going to be stored as 60. Because why we have said the value the user is entering, store that value in array called marks index I. So index I means the current value of I is 4. So index 4, we're going to store the value as 60. Is that part clear? Okay. Next, we have total is equal to total plus marks. Total is 0, marks I. Okay, so marks I is basically marks 4, right? So marks 4 is having the value of 60. So 60 plus 0 is equal to 60. So I update that here. Is that clear? Okay. Next, we have the end. So in for loop, we have when you have multiple instructions of for loop, we start with begin and we finish at the end. So these are collection of instructions within the for loop. So after you reach the end of this, what happens in a for loop is like these are the instructions within the for loop. So once you're done following the instruction within the for loop, automatically you'll increase the value of I if it's for to do loop, and automatically you'll decrease the value if it's for down to loop. Now here it's for down to no, so we're going to automatic decrease. So automatically, if I decrease the value of I, what is the next value of I? It's going to be 3. So I'm going to tell the value of I is now 3. And now after I becomes 3, we'll again follow the instruction. So first instruction is write ln enter marks, which means we're asking the user to enter marks. And now read ln marks, we're going to store the value the user enters. So now we're going to store the value in the array called marks index I. Now I is 3 now. So inside index 3, we're going to store the value. So our first marks was 60. What is second marks? Second student's marks? 90. So index 3, we're going to go and store the value as 90. Is that clear? Okay. The next instruction is total is equal total plus marks. So total is currently 60 and the marks I is 90. 60 plus 90 is 150. Got it? Is that clear? Okay. When you reach end, you again automatically decrease. So when you again automatically decrease, the 3 will become 2. Again, we are asking to enter the marks. We're going to store the marks the user entered, but now we are going to store an array called marks index I. I is now 2, so now we are going to store an index 2. So the third marks the user gave is 82, so we're going to store 82 in the second index. Then again, we have total equals total plus marks. Currently, total is 150. The marks entered was 82. So 150 plus 82, that's 232. So update here. The next instruction end, when you reach and you again going to automatic decrease. So now for 2 is going to become 1. And you're going to follow the instructions inside. So first write in enter marks, we are asking the user to enter the marks. Then radial in marks I, we're going to store the marks entered. That's 45. So we're going to store in marks I. Currently marks I is 1. So we're going to store in index 1, the marks is 45. Then total equals total plus marks I. Currently total is 232. Marks 1 is 45. So 232 plus 45 is 277. Again, come and automatically decrease. So now when you decrease 1, it's going to become 0. Again, we are asking to enter the marks. So when you ask to enter the marks, the user is giving 92. That 92, we are going to store in array called marks index I. Currently, I is 0. So we are going to store in the 0 index as 92. And then after we store in the 0 index as 92, what do you call the next we have total equals total plus marks. Currently total is 277. So for 277, we're going to add 92. So 277 92 is 377, 367, 369. When you reach that, you try to go and reduce the value of I. Now we can't reduce more because we have said the starting value is 4 and ending value is 0. So because the ending value is 0, we're going to stop from there. Okay. So the for loop finishes from there and we're going to continue the program. Is that part clear? Okay. Next instruction, write ln total is total. So that means the output is going to be there as, so we have output there. The output is going to be total is, and you can see they have mentioned the variable's total value. So variable total's value is how much currently? Correct. 369. And next we have read ln. Nothing is going to happen by that. That is normally mentioned for the program not to get over. So the program window will be as it is. That's not relevant here. Can ignore it. Nothing is happening there. So, yeah, so the output is going to be total is 369. And this is how the values will be stored in the table as well. Is this part clear? Perfect. Next, consider the following pseudocode. 4x equals 0, blah, 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 marks, blah, blah, blah. Enter data the following marks array according to the above pseudocode. Okay, so there's a marks array. Normal index starts with 0. So if you look at this program, there's a variable called x. X is a starting value of 0. Okay. So we have here for x equals 0 to 9, step 1. Step 1 means automatically increase y by 1. I don't for loop, it automatically increases. So if you want to automatically increase it by 2, you can mention step 2. if you want automatically increase by 3, you can mention step 3, something like that. So step is used to tell increase by how much. Is that clear? So here there is nothing big to worry about the word called step. Okay. So x is equal to 0. And when x is 0, we're going to follow the instruction inside. That is mark x equals x into x. That means array call marks index x. X is how much? X is 0. Index call 0. The value is going to be equal to x into x. That is 0 times 0. So 0 times 0 answer is 0. So value in array index 0 is going to be 0. When you say next x, that means go for the next value of x. Okay. So when you go for the next value of x, now x is going to become 1. When x is 1, again, we're going to follow the instruction. So when you say marks x, that means array call marks index 1, the value is going to be equal to x into x. That is 1 into 1. So 1 into 1 is equal to 1. So marks index 1, the value is 1. Is that clear? Next we say next x. So now the index is going to be 2. So when you say that, the meaning of that is marks index 2, the value is equal to 2 times 2. So 2 times 2 is equal to 4. So index 2 value is equal to 4. Got it? So in that, so the element is not mentioned there, right? So do we need to write it as write it compulsory? You mean this 014 or 0123? 0123 is not called the element, they are called the index. It is not mentioned, but it's better you mention it. So there are chances they would expect it as well, so better mention it. Okay. So if you continue like running the program, when you continue running the program, you will have a 3 times 3 as 9, 4 times 4 as 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81. So if you continue running the program, this is how the um, array will look like. Clear? Any other questions? Yes, and I'll do it. Give me, you send the question until I think 410 come back. Throat is gone for 6. Send keep in the chat, I'll come. Give me a moment. Okay, I'm back. The filters water was over, so I had to go and buy the water and come. No, no, sorry, I just said my throat is gone for 6 7. Okay, let me check. The A, B, C, or D, or all four? Which one? Okay, let's start. So the question says refer the Pascal program given regarding arrays. Assume that the given code is executed once and complete the grid in figure 1. Okay. So there's a array called ARR, and here the range of index are from 1 to 5. So that means index 1, index 2, index 3, index 4, index 5. And then they have mentioned ARR 1 is equal to 13, 2 is equal to 5, 3 is equal to 7, 4 equals 1, 5 equals array 3 minus 1. So 3 is 7, 1 is 13. So 7 minus 13 is basically 6. It's 6, 8. Sorry, 6, right? 7 minus 13 is minus 6, right? Yeah, I'm breathing at the moment because I ran and went to buy the bottle and cup. So yeah, it's minus 6. So basically, the value of index 5 is basically minus 6. So 7 minus 13 can 7, 8, 9, 10, 11, 12, 13. Yes, minus 6. Next, if, yeah, so I wrote minus 6 there. If index 5 value is less than 0, is the index 5 less than 0? Yes. Then we have to follow this instruction. What is the instruction we have? Index 1 is equal to index 1 plus index 4. Index 1 we have 5. Index 4 we have 5. So they are saying index 1 is equal to index 1 plus index 1 plus index 4. Index 4 we have 1. So 5 plus 1 is 6. So then we can say the value in index 1 has to change. It has to become 6. Are you clear how I found out the value is 6 there? Okay. Should I follow the instruction, this instruction? Hmm? What do you think? Should I follow this instruction, this line basically? No. If you look at the situation here, we have a condition. In if statement, if the condition is true, you follow the instructions between then and else. If the condition is false, then you follow the instruction after else. Now, in this question, did the condition give us true or false? The condition we had is 6 less than 0. Array 5 is less than 0. No? Is array 5 less than 0? In array 5, we had the value as minus 6. Is minus 6 less than 0? Yes. So that means what was the result of the condition? True or false? Hmm? It was true. So because it's true only, I follow this instruction. So because it's true, I follow only this instruction. I follow the bottom only if it's false. So at the moment, I'm going to ignore it because the condition was true. Got it? Okay. Then we have for A equals B to C do blah blah blah. The question is saying, okay, for the question A, this is how the answer is going to be 13, 6, 7, 1 minus 6. For question B, they have mentioned fill the blanks A to D, that's A, B, C, D, required to print the values of the above array. Okay, they're asking to print what you call find to print the values of the above array. Now, if you want to print the values of the above array, we have to print it one by one, which means first we have to print the index 1 value, second you have to print the index 2 value, next to print the index 3 value. We will change the first one to 6, right? Sorry. No, first one to 6, not the second one to 6. My bad. I changed the second one to 6. It should have been something like this, no? 13, 5. So we say index 1 is equal to index 1 plus index 4. No? So index 1 value is 13. Index 4 value is 1. So 13 plus 1 is 14. So this has to become 14. Okay. Earlier I made 6 as a mistake because I took that as index 1. But this is in the question is not going from index 0. This question is going from index 1 now. So index 1 we had was earlier 13. So I add the index 1 and index 4 value. That was 13 plus 1, 14. Got it? So they are saying to find the values of A to D to print the values of the array. That means first of all, we have to print the index 1 value, then index 2 value, index 3 value, index 4 value. One by one, we have to increase it. So then it's going to be, we have to start with, we have to use a, first of all, in a for loop, we have to use a variable. If you go through this whole program, apart from the array called ARR, there was another variable declared. What is the name of that variable declared? Exactly. You can see there was a variable called I that was declared. So I'm going to say for I equals, and what the starting value is index 1. No? So like for I equals 1 to 5, because last index we have is 5. So I'm going to be like for I equals 1 to 5. Okay. For I equals 1 to 5 do write ln the array called ARR index I. So first it will display the index 1 value, the index 2 value, and the one rotating. So A is representing the letter I, B is representing number 1, C is representing number 5, and D is representing ARR index I. Is that clear? Yeah. So that's how that question works. Next. The following flowchart in figure 2 has been drawn to calculate the total of first 10 numbers from 1 to 10. Write down the most suitable replacements for its labels P to T. Okay, so the purpose of flowchart is to calculate the total of the first 10 numbers from 1 to 10. That means from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the purpose of this program is to calculate the total of this. That means the sum of all of this. First of all, tell me by reading the question, are you clear what is the purpose of the flowchart? Like, did you get the idea of the purpose? Okay, because without knowing the purpose, you can't do the question. Okay. Hmm. Yeah. When you're starting the program, you can see there's a variable called C and there's a variable called total. So initially we have mentioned C as 1 and total as 0. Then we're going to come and check here if C is less than something. Okay. less than or equal. If C is less than or equal, again, they're not mentioned in yes or no direction. This should be the no and this should be yes, actually. That's not mentioned here. So if C is less than or equal to a specific number, you can see we're increasing the value of total. Okay, or we're changing the value of total. After we change the value of total, you can see we're changing the value of C as well. And after you change the value of C, you're again coming and checking the value of C. Now, tell me, if I ask you to find the total of all of this, just by looking at the number, at once using your brain, can we add all these numbers in one shot? No. So if I ask you to find the total of this without using a calculator, if you're going to like manually calculate, first of all, what are you going to do? I ask what is the total of those answers. What are you going to do first? What's the first step you will do? Add one by one. So first what you're going to do is you're going to add 1 and 2, right? So when you add 1 and 2 together, what's the answer? 3. After you get 3, what's your next step? Correct. You're going to add the next number. So 3 plus 3 is going to be 6. What's your next step? Exactly. 6 plus 14. So if you notice here, what you're doing here is you're adding two numbers. So you're adding a number. Okay, you're having the number and you're adding that number and the next number. So after you get these numbers, you get a total now. For this total, you add the next number. And then for that total, you add the next number. So you can see you have a total and you have a next number, total and next number, total next number, right? So in this program, what's happening is we're starting with C as 1. Okay, we are starting C as 1. And what we're doing is we're saying total is 0. So C is 1, total is 0. And what's going to happen here is in order for you to find the sum of all 10 numbers, we can't do it once, just like how humans we can't do it as one. Same thing computer as well. Computer can't do all this as once. So imagine we have this total as a big box. What we do is little by little, one by one, we add that C. So first we add the 1 to total. It's imagine like adding scoops. Okay, imagine for example, you're making tea and you have a big jug and you're adding the what do you call sugar or you're adding milk powder. And you add spoon by spoon, right? Same thing here as well. First you add the first value of C. First you add 1. Then you add the 2. Then you add the 3. Then you add the 4. So C is going to use to navigate that each and every number. So initially C is going to be 1 and then C is going to go for the next number, which is 2. What total is going to do is initially total was 0 and we are going to add the C for it. So we can say, we can tell that for the variable Q, we can have the equation as total is equal to total plus C, which means for the total variable, I'm saying at the value of take the current value of total and for the current value of total, add that C. So initially if total was 0, we are asking to add 1. So 0 plus 1 is equal to 1. And then here we are going to say C equals C plus 1. That is to go for the next number. So when you say C equals C plus 1, currently C is 1. When you say C plus 1, 1 plus 1 is going to be 2. So C is going to become 2. So then again, you're going to come and check the condition. Is C less than or equal to something? I'll tell you what that something is in a while, wait. Okay, and if C is less than that, then you're going to say yes. And again, add that C as well, total. So now when you say total equals total plus C, currently total is 1, C is 2. So 1 plus 2 is 3. Then you have total equals C plus 1. All this time C was 2, no? So when you say C equals C plus 1, that's 2 plus 1, C becomes 3. Then again you go and check is C less than or equal to P. Yes, total equals total plus C. So currently total is 3, C is 3. 3 plus 3 is 6. C equals C plus 1, C becomes 4. Again you go and check is C less than or equal to P. It's going to be yes. Total equals total plus C. Currently total is 6. C is 4. 6 plus 4 is 10. Then C equals C plus 1. C is going to become 5. It keeps on increasing like that. P equals 10, right? Yeah, P is 10. Tell me, are you clear first of all how I got Q and R? So the same way how humans we do only, programs also going to do. And then the variable P is normally the condition in this kind of repetitions. A condition is used to control the repetition. So these two instructions should be repeated multiple times. These two instructions, it has to be repeated multiple times. But there's a limit. It has to be repeated until 10 is added. After 10 is added, now let's say for total, we are adding one by one for total. First of all, we add 1, then we add 2, then we add 3. After 10 is added, is there anything else extra to add? No. So that means we want the instruction total equals total plus 10. We want this to run. Okay, total equals total plus 10. We want this to run. Okay, so when you say total equals total plus C, when C is 10, it has to run. When the value of C is 10, it has to run. But after that, we have C equals C plus 1. No. When you run the instruction C equals C plus 1, C will become 11. When C becomes 11, this instruction has to be false. So we have to figure out a value we can mention here as such that when it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, from 1 to 10, it will give the answer as yes. Once it becomes 11, it has to give no. So for that, the most suitable value is mentioning P as 10. So if you mention P as 10, it will be properly. I mean, that's how you decide. Got it? So this is P, this is Q, and R. Next, display S and T. So S is going to be something you can see inside inverted comma. Inside inverted comma, we mention a text. And inside here, after the comma, we have something without inverted comma. So we can say inside inverted comma that S has to be something like, let's say, the sum of or the total of first 10 numbers. The total of first 10 numbers. We can mention a plain English text. The total of first 10 numbers is. So I'm going to say the total of first 10 numbers is. And T, you can see it's mentioned after the comma without inverted comma. So that means T should represent a variable. So we can say the total of the first 10 numbers is TOT. That's what SNT is. Is that clear? Perfect. So next question they are saying, modify and redraw the above flowchart to calculate the total of any 10 numbers, different integers, any 10 different integers entered by the user. Now currently you can see we're adding only the defined numbers. It's 1, 2, 3, 4, 5, 6, a specific defined number only we're adding. Okay. To allow the user to add any random number, we'll first of all ask the user no. So how that will work is something like this. How that's going to work is before the instruction called total equals total plus C. Before this instruction, it will be something like this. There will be one instruction saying input number. Okay, there will be one instruction saying input num. And the next instruction will be total equals total plus num. After that instruction, come here. So therefore, this one will be there. The same flowchart, only difference is without directly saying total equals total plus C, we add a part called input num and we add that number instead of adding C. Now here we are saying total equals total plus C, no? So without saying total equals total plus C, we'll be telling something like total equals total plus num. So then the number the user gave will get added. Is that clear? So same flowchart, only one difference. That is, we'll have the input num. If you want, I can show the flowchart. I think we did this program in the class. So if I go here for the programming tute, grade 11, lesson 1. We did that question somewhere here. Right, right. No, we did that in the class, I'm saying. Here. Here how the pseudocode is. You want the flowchart? No, we did flowchart also. Flowchart is this. No, this is sum of all odd numbers. In random numbers is no, this is until the enter number greater than 10. Yeah, the program until you enter number greater than 10, sum of all odd numbers. No. I had written a pseudocode, we have not done the flowchart. Flowchart is a different question. This is sum of all odd numbers, no? This is a question. Get 10 numbers and find the total and average. Here I'm finding total average both. So this is pseudocode. You just have to convert this pseudocode to a flowchart. Anyways, any other questions? Any other questions? I am not sleepy. Okay, so as there's no other questions, I'm gonna end the meeting. Have a nice day. Bye bye.